So we kind of stopped somewhere around here, and I believe you must have got enough time and gave some thought process to how to get the answer. All right, so here I have kind of redrawn a bit just to remove a bit of clumsiness from the previous diagram. A lot of things had gone into it. So we kind of stopped here. We found the point B by kind of identifying the distance as well as track from the question. Right, so the whole idea is to currently find out this particular latitude and this particular longitude, which will kind of fix the point B. So a couple of data which we know, let's put it here. We know the B is kind of 100 nautical miles from A. So this is the question again for you to kind of refer just in case if you haven't. All right. Okay, and we also know that the track from A to B is 225 degrees. So with these information, we kind of reached right here. Now, if you look at this particular triangle, which is formed by A, O, and B, I can write directly that this particular angle is 90 degrees. Why? Because meridians and parallels of latitude, they intersect at 90 degrees. Pretty basic knowledge, right? Okay, so what I'm going to do right now is I'm going to take this triangle AOB, which is a right angle triangle, right angle at O, to our basic mode page, which is right here. You can see all the previous diagrams right here, and from there, all right, so let's get into this basic page dark mode, right? And now let's draw the triangle, the exact triangle which we just identified over there, formed between the points A, O, and B, right angled at B, right? So the triangle is kind of made by three different sides, obviously, one of which we know as a hypotenuse because of the right angle triangle. And the OA is the height, which we would call as the opposite side, right? And OB is the base. And for us, it is the adjacent side. Perfect. So what we are going to apply here is we are trying to find out the distances OA and OB. Now, what is the advantage of finding the distances OA and OB is that once distances are known, you can kind of find the lat and long, and that will eventually take you to the lat and long of point B. Okay, so let's get started. For that, we need to apply trigonometry. Now, trigonometry is something which kind of really messes around with people. So I have done a couple of other videos on trigonometry. You can definitely go check them out. Or you can just let me know, drop in the chat, or you can just comment out and I'll definitely get back to you. What trigonometry says is that for a right angle triangle, and only for a right angle triangle, if I know a particular angle, and if I know any of the three sides, whether it be hypotenuse, the opposite side, or adjacent side, then I can find all the other sides. And obviously the other angle as well. All right, so whole idea is we know what a hypotenuse here is here in this question, that is 100 nautical miles, distance between A and B, right? If we can find the angle theta, then I can find out the opposite side and the adjacent side, right? Now let's put the relationship between this theta and the opposite and adjacent side over here. So the known angle and its opposite side, as you know, is connected by the trigonometric function, which is sine theta. Sine theta is nothing but opposite side by hypotenuse. Pretty simple, right? Similarly, the trig function which connects the adjacent side with the hypotenuse is the cosine function. So cos theta, which is adjacent side by hypotenuse. All right, so hypotenuse is equal to 100 nautical miles. So now we are trying to find out the opposite side and adjacent side, and then we'll find lat and long and end up reaching at B. All right, so let's find out the opposite side. So for that, we need to first find out the angle theta. So this is the whole idea, is to find the angle theta first. So let's go back to our basic diagram over here. Perfect. Now, again, as I said, try to draw a bigger diagram. Perfect. Now let's see. We are looking at the angle theta right here. Perfect. Now we know that from the north, which is indicated by the local meridian, clockwise is 225 degrees being tracked from A to B, right? But we also know that so much of an angle is 180. It's north to south, so it's 180, right? Therefore, what remains here is 45 degree. This particular angle over here is 45 degree. Perfect. So this being 45 degree and this being a right angle triangle, this theta is also 45 degree. You can find out this particular, the sides using any of these angles, right? Now the peculiarity with a 45 degree right angle triangle is that, let's go back to the basic figure again. Now it's quite simple for us here, because theta being 45 degree, for a right angle triangle, for the opposite side is equal to adjacent side. So when you find opposite side, and that's exactly equal to the adjacent side. So we're kind of doing it as if it's not equal, just to show you how it's done. All right. So with this known angle of 45 degree and known side of hypotenuse, let's find out the opposite side using sine function, and adjacent side using the cos trig function. So we know that to find out the opposite side, you simply have to multiply sine theta with hypotenuse. So the opposite side is sine 45 into hypotenuse, which is 100, and that is going to amount to 70.7 nautical miles. And since the right angle triangle being having the angle 45 degree, and the adjacent side is also going to be 45, but let's find out, to find the adjacent side you have to multiply cos theta with hypotenuse. So adjacent side is equal to cos theta being 45 multiplied by 100, and if you know, cos 45 is equal to sine 45, and it's 1 by root 2, right? And that's going to give you 70.7 nautical miles, right? So once you get the opposite side and the adjacent side, we'll go back to the previous figure and we'll try to kind of find out the Chilat and Chilong. Perfect. All right. So getting back to the previous figure over here, so this particular distance from A to O is 70.7 nautical miles, and so as the distance from O to B, which is again 70.7 nautical miles. Now it's pretty simple. Now you know where am I going, kind of, right? The distance from A to O is actually made through a meridian, which means it's a great circle, and therefore 1 nautical mile is equal to 1 minute. Perfect. So let's take these values back to the previous figure right here, or probably let's draw a new figure. That's fine, we have enough and more pages. So let's get the triangle drawn here straight. This is A, O, and B. So we got this side as 70.7 nautical miles, and so as this side as 70.7 nautical miles. So we know the side OA is made up of a meridian. Perfect, right? And the side OB is made up of parallel of latitude. All right. Now, the side OA is along a meridian, and therefore 70.7 nautical mile is nothing but 70.7 minutes. That's because if you travel through a great circle, we know that 1 minute is equal to 1 nautical miles, right? Let's convert this to degrees. So using your scientific calculator, you can kind of convert that to degrees. 70.7 divided by 60. Perfect. And that's going to give me 1 degree and kind of 10 minutes and 45 seconds, or kind of take it as 10 minutes. You can also expect 11 minutes in the answer as well, because it's close to 11 minutes, right? So 1 degree, 10 minutes. Now we know that we were initially on the equator from the question. So from the equator, if you travel south by 1 degree, 10 minutes, now this is the basic, I understand that you know all these things, we will end up reaching 1 degree, 10 minutes, or in the answer, you can even probably find 11 minutes south. All right. Now, from this particular meridian, which is 130 degree east from the question, you are traveling westward again for 70.7 nautical miles, and therefore let's find out what the Chilong there is. So what we got here is nothing but the Chilat, right? And what we're going to find out while traveling from O to B is the Chilong, right? And here is when, for the first time in this question, we kind of use the departure equation, right? So departure equation, we know departure in nautical mile is nothing but Chilong. Now, this is the first point which you have to understand. I have had numerous number of students who make mistake in this, especially convergency and departure being very adjacent chapters, and they get confused once they learn both of them, right? So Chilong is always in minutes, because its departure is in distance, and distance has to do with minute, not degrees, multiplied with. Now another mistake which people commonly make is a trig function that they associate departure and trigonometry with. So for departure, it is cosine function of the latitude, right? Now, it is very important to understand that for you to apply a departure equation, the travel has to be made through a particular parallel of latitude. In this particular question, you couldn't probably apply the departure equation straight away, because our travel actually is not along a particular parallel of latitude. You deviate away from the equator, and you can see finally we are on 1 degree 10 minutes south. Therefore, departure equation cannot be applied directly. All right. Now, since from O to B we are traveling along 1 degree 10 minutes south parallel of latitude, a departure equation can be applied directly. So let's apply the values to departure equation. We know the departure, which we just found out, as 70.7 nautical miles. We are supposed to find out Geelong, and the Geelong in minutes multiplied by the cos of latitude, and we are on 1 degree 10 minutes latitude, right? So therefore Geelong is equal to, let's find out again using your scientific calculator. It's going to be 70.7 divided by cosine of 1 degree 10 minutes. Well, that's kind of giving us 1 degree and 10 minutes. So I kind of converted the minutes to degrees here. So it's 1 degree 10 minutes again. So now we are traveling from O to B, and as you travel over 70.7 nautical miles, since the chilat is not that much, the departure is kind of almost the same, and that will give you a Geelong of 1 degree and 10 minutes. So from 130 degrees east, which is right here, you're moving westward over 1 degree 10 minutes. So remember, from an eastern longitude, you're moving westward. The value of the eastern longitude, which is the eastern meridian, which is the longitude, kind of reduces, right? So having drawn that particular meridian here, this meridian is going to be 130 minus 1 degree 10 minutes. That's going to be 128 degrees 50 minutes east. All right, so we kind of derived the lat and long of point B straight away. You can see point B is on 1 degree 10 minutes south and 128 degree 50 minutes east. All right, so let's put these values straight into the options here to find out the right answer. You can see, as I told you, it could be 1 degree 11 minutes because it's close to 11 minutes. You can see option A right away as 1 degree 11 minutes south and 128 degrees 50 minutes, which is around 49 minutes east. So that being the answer. That's it. If you have questions, do let me know. I kind of gave you some time to kind of think around it. So I've got a couple of other solutions for this particular problem. It's more like from experience point of view. So when you look at the question, you kind of have this feeling of what the answer would be.